Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about position and displacement vector. If a body is in motion, its position changes with respect to time. If a body is at rest, its position does not change. So, based on the position changes or not, we can say that a body is at rest or in motion. How we can specify the position of an object? Look at here. So, here I am considered as a tree. Okay, a person is standing here. Okay, this person is 5 meters from this. So, I want to define the position of this object. So, I can say that a person is standing 5 meters away from a tree in northeast direction. You can see the direction. This is the north and this is the east. Okay, a person is standing 5 meters away from a tree towards northeast direction. Okay, this way I can specify the position of an object. So here I am considered the tree as the reference point. Okay, so always we will define the position by considering a reference point. Okay, so this is the way in the real life we will discuss. Okay, the position. In mathematically, we are using the rectangular coordinate system to define the position. We will see how we can apply the rectangular coordinate system. Okay, so this is the x-axis and this is the y-axis. This is the origin. There is a point P is here. Okay, so I can say that this point P is OP distance from the origin. Okay, and its direction is this. Okay, from the origin, this point is in this direction. So OP, I can say that the position vector. This position vector, this vector gives the magnitude to, that means the distance from the origin to this point and from origin which direction this point is situated. Okay, so now we can define the position vector. What is position vector? Position vector. Position vector gives the position of an object. Position of an object. Okay, so the position vector is always originated from the origin and end at that point. Okay, it is always originated from the point and end at the point. Okay, clear? Then if I am consider this position vector is an R and this point is X and Y. Okay, then I can say that this R vector is equal to Xi plus Yj. Clear? Xi plus Yj. This is the position vector of the point P. Okay, this is about the position vector. Now we will see what is displacement or displacement vector. Displacement vector. What is displacement? Displacement is the change in position of an object in a specific direction. Specific direction. It is the shortest distance between initial and final position. So I am consider a plane. This is the x-axis and this is the y-axis. So I consider as a curved motion. Okay, This is the curved motion. In the initial point is P1 and the final point is P2. Okay. So here, what about the position vector of the initial point? That I am considered as R1, and the position vector of the final point, that is the P2, is R2. Okay. I need to find out the displacement. Displacement is always a shortest distance. So shortest distance is a straight line. So you can say that this is the displacement vector. So the displacement vector is from initial position towards the final position. Okay. So this point P1 and P2, I can say that displacement vector. Okay. P1, P2 is a displacement vector. Okay. This vector magnitude gives the magnitude of the displacement, and the direction is the direction of the displacement. The direction of the displacement is always from initial point and towards the final point. Okay. Then now you see this. The position vector of the P1 is R1 and the position vector of P2 is R2. Okay. Based on the triangular law of vector addition, the R1 and P1, P2 are the adjacent sides of a triangle and are in the same order. Then R2 we can consider as the resultant, because it is the third side that is to be in the opposite order. So I can say that R1 plus P1, P2 vector. This is also a vector. Okay. So P1, P2 vector is equal to R2 vector. Okay. Then what about P1, P2 vector? P1, P2 vector is R2 vector minus R1 vector. This I am taking as a delta R. Okay. I am giving the symbol delta R, change in position. So R2 minus R1. What is R2? R2 is the final position vector minus initial position vector. So this is the displacement vector. This way you can find out the displacement vector. Here delta R is the displacement vector. It is the difference between the final position vector minus initial position vector. Okay. If P1 is x1, y1. Okay, and P2 is x2, y2. Okay, then what about R1 vector? R1 vector is equal to x1i plus y1j, and R2 vector is equal to x2i plus y2j. Okay, now we can find out the delta R. What about the delta R? Delta R is equal to R2. What about R2? x2i plus y2j minus R1, that is x1 I plus y1j. That means I time around you take it, x2 minus x1 into I minus y2 minus y1 into j. This is what? Change in the x component, that is delta xi plus, this is what? Sorry, if it is to be plus here, this is y2 minus y1. So delta yj. Okay, this is delta R. Okay, delta R is a displacement vector. Clear? Okay, this is about the position vector and displacement vector.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.